time for some practice problems. All right, here we go. First thing first, we factor x minus 3, x minus 1 over x minus 3, x plus 2. All right, so I know in my problem right now, based on this, x cannot be 3, x cannot be negative 2. Cancel, cancel. X minus 1 over x plus 2. Due to that, the fact that x plus 2 is left in my denominator, my vertical asymptote is negative 2, while the x value of my whole is 3. Right, so I'm going to start graphing this up right away. X equals negative 2. So if I plug in 3, I got 3 minus 1 over 3 plus 2, 2 over 5. So my whole is at 2/5. 1, 2, 3, 2/5. 3, 3, 2/5. There's my whole. All right, my horizontal asymptote. Since the numerator has a degree of 1, since the denominator has a degree of 1, my horizontal is the ratio of the lead coefficients. 1 over 1 is 1. Y equals 1. My x-intercept. I set my numerator equals 0 and solve. So my x-intercept is 1, 0. My y-intercept. I plug in 0. 0 minus 1, 0 plus 2, negative 1 over 2. My y-intercept is 0, negative a half. Down there. All right, so I see this curve. I got a lot of points here. I got enough points to see this curve instantly. Right? Take some time, fill in the chart, and when you fill in the chart, you get enough points to see that curve too. All right, next example. How do we start this off? We factor. So I got x plus 5, x minus 3 over x minus 3. X cannot be 3 because that's our only restriction that's left, started in the denominator and ended in the denominator. We cancel. We are just left with x plus 5. So since we do not have a denominator, there is no vertical asymptote. There's nothing left in our denominator. That means that 3 is the x value of our whole. So I plug in 3 plus 5, that gives me 8. So my whole is 3, 8. My horizontal asymptote, it's based on degrees. Well, if it helps, I got x plus 5 over 1. This has a degree of 1. This has a degree of nothing. So in this situation, our numerator has a larger degree than our denominator. So there is no horizontal asymptote. All right, x-intercept. Set our numerator equals 0 and solve. So I got negative 5, 0. Y-intercept. Plug in 0 for x and solve. 0, 5. Now, what am I really left with here? I'm left with, in this situation, not y, I'm left with f of x equals x plus 5. What is this? This is a line, right? We are left with a line. So I got my y-intercept at 0, 5. I got my x-intercept at negative 5, 0. I have my whole at 3, 8. I got no vertical, no horizontal. So hey, in this situation, when all is said and done, we have a line with a hole. That's okay. Nothing wrong with having that. And again, take some time, fill in the chart, get some extra points, know for sure that what you have is correct. All right, one more example I'm going to do together. So what do? We factor. GCF. X squared minus 6x plus 5. 3, x minus 5, x minus 1 over x minus 3, x minus 1. X cannot be 3 or 1. Vertical asymptote in this situation, well, cancel, cancel. 3, x minus 5, or x minus 3. So since x minus 3 is left, x equals 3 is our vertical. My holes. I have 1, comma, well, let's see. 3, 1 minus 5 over 1 minus 3. 3 times negative 4 over negative 2. Negative 12 over negative 2. 1 comma 6. All right, horizontal asymptote. Well, we look at our degrees. They both have a degree of 1. So it's the ratio of our lead coefficients, which is 3 over 1, which is 3. All right, so here's my horizontal coming through. Y equals 3. What is my x-intercept? Well, I set my numerator equal to 0 and solve. All right, divide by 3 gives me x minus 5 equals 0, x equals 5. So my x-intercept is 5, comma 0. For my y-intercept, 0 minus 5 over 0 minus 3. 3 times negative 5 over negative 3. My y-intercept in this situation, negative 15 over negative 3 is 5. Will they always be opposites of each other like we had in our original problem? No. Sometimes it happens, sometimes it doesn't. So I got 0, 5 up here. And I got my 5, 0, 3, 4, 5 down there. And again, what do? Take a moment, fill in the chart. Get some more points. Know for sure that your information is correct. All right, hit that, go up. Come to this point, up, and this point down. And again, we'd have some more points to graph to know that our graph is 100% okay.